Hello, Professor. My name's Nathan Sexton. This is Lab 3, Conservation of Momentum. As far as it goes, this is a relatively simple lab where, it was described in the lab, we're demonstrating the transfers of momentum similar to using Newton's cradle. The velocity of a marble after impact depends on its original velocity and the mass of the objects at hand. So for this actual experiment here, I'm using my phone instead of usually my laptop so we can actually get a better view of this. So I'll turn the camera around and So first off, we got two parallel rulers. I got them taped at the end in order to make sure they don't move or stay down. And then we have 5 marbles. Well, here we are. Now we have 5 marbles going through. So this is the flattest surface I have. The desks didn't really work as well. So we're gonna, in part 1, you line up 4 marbles in the center of the runway and ensure they're all touching. Go through. Alright. And it's not perfectly level. Source of error in this experiment. And it's one of the problems that I'll explain a little bit later. We're going to take the marble placed at one end of the runway. I placed mine on the left. And we're going to flick it so that it goes through and collides with the others. Alright. So, the 4 stationary marbles, it shot off one to the end as well. After that, there's different speeds that we're going to be going through, and then we're going to end up going through. And let me look at the table here, and then I'd better. So this is explaining the other steps where we're going to flick it 1 marble, then 4, and into 4 stationary, then 2 flicked marbles into 3 stationary. All of my tables are filled out in the workbook, but this is a precursor, so we're not going to go through that as much, but the answers will be there in the workbook itself for after the experiment. But we're going through trying to do a couple different things, and then in part 2, we're going to, same thing, line up our runway, and then we're identifying left and right ends of the runway, line up marble, and then we're doing a head-on elastic collision and recording the ones that are left on the right and left side of the runway. And this is for table 2, going through different speeds and changes from there. So to explain this a little bit better, this is what we call an elastic collision. So with the marbles, although they aren't the most elastic thing, they are relatively, they're also rigid. So when it goes through and they actually strike each other, the energy from the first marble, instead of going through and causing all of them to move, will strike, and the energy is transferred right here to the marble at the end. During the elastic collision, the elastic energy dictates that it'll transfer, and then it'll hit till the end where it'll finally release the energy, because at that point it has nowhere to go. The striking marble, which would be this one, in this closed system, it transfers down the line because of the properties at play, and the amount of energy is the same throughout the system, and it transfers its energy until it's released at the very end. But there isn't any less energy in the system. It's merely being transferred due to the collision itself. As far as it goes, when I was going through this experiment, I did see a couple issues that could occur. Not having a complete level surface would cause the marbles not to stick the way you wanted them to when you were setting them up, or stray from the center. But all in all, it does do a very good job of explaining Newton's cradle and conservation of momentum as a whole. Let's see if we have anything else. No, that should be it. I look forward to having you read over my work in the workbook, seeing how I did, and going forward from that. This was a really interesting experiment, and I think it did a great job of explaining conservation momentum, and especially elastic collisions, where energy is transferred throughout the system to the very end, instead of where in a non-elastic collision this would be striking here and this would all tend to stick together. I hope you have a great day, and I'll see you next time.